Morning. Thank you for joining today's class. A quick introduction about the course. It's a object-oriented programming. So, but the language you are going to make reference to is we are going to make use of Java because by and it's C++. So Java by default is meant to be an object-oriented program. So that was why we choose it. And as a prerequisite to this course, you must have done one or two programming language before. So hopefully, in our previous semesters, we prepared that. We've done Python programming, we've done visual programming, for example, Scratch, and we've also worked through C as a language. C is not object oriented, and that was the intention it has. And a quick one, Sha. So, first of all, let's understand the concept of object-oriented. Objects, from the word object, like your real life object, it simply means object per se. Because what makes an object or a material is that it has two things, which is the state and the word behavior. So let's quickly run through the overview or history of object-oriented. Object-oriented programming, also known as OOP, is a programming paradigm that uses object data structures consisting of data, fields, and methods, and their interactions to design and applications and computer programs. So what are we trying to say at this point? This is a set of programs. Before now, we're already used to procedural programming, and you are equally introduced object-oriented programming in Python. So, but the emphasis on this course is that we are treating the paradigms. That's this set of programming paradigm called object-oriented, whereby we don't just create things, we make them as a template, so that we can reuse them and it can be implemented, and those objects can interact with itself. All right. Then this object-oriented programming came into play mainly in as far back as 1960s. So the limitation would have brought it is that they found out that when software development or when technology keep on advancing, so there was need for scalability, and they have a challenge whereby the the standard of production differs and is with the same name, and differs in the same with the same name, and the quality keep on increasing. So that was how they resolved to object-oriented programming. Let's digress a little. When you talk of objects, for example, if you've noticed your conventional product, for example, your Coca-Cola, your plastics, you notice that all of them are the same. So what did they do? How do they achieve it? They must have developed what we call a template or a model whereby they can cast, for example, in plastic, they will develop a standard model. They simply melt the plastic and cast it inside it. So even if they produce 1 million plastics, all those 1 million are exactly alike. If you want to change the design, they have to go and change the model. They are not changing the content of the plastic. They are changing the model, and it will not affect any other thing. The production of the processing sector of mixing the plastic materials, they just change the model and they will get a new design. So also what we are going to have in this object-oriented programming, anything we want to do, we make it in a model such that when the application gets to scale more higher, we could choose to change only that module without affecting the other part of the program. So I think we've dwelt a lot of in the history part of it. Okay. Then the next thing we have is the object and classes. We're going to only emphasize on object because class is related to object. So when you talk of an object in program simply means just like we have in our variables that stores values. But this part of the object is stores what we call both a state and a behavior. It stores states and behavior. So these states can be seen inside. We can make use of variables to get a state of an object, and then we make use of methods to get the function of an object. I hope you understand. Hope you guys understand what I meant. So, for instance, now, if we have a car, let me check it. If I have a car, for example, a car ideally should look like this, right? I got it right. Let's say that this is a car, then this is the tire, right? And now the windows. So this is a state of the car. You understand? So whenever you see a structure like this, it suggests something to you that it's a car. But going ahead, we'll have another set of it. This car cannot be car if it cannot move. So we have gotten the first method. It cannot move. It is neither a car. The major method of a car is that it's moving. So the moving state also differs. How fast it is, how good the engine, and so on and so forth. So when you talk of an object, you talk of the first of all, the states and the behavior. The states simply means how the object looks like, or what is it all about. Then the behavior, what makes that object to behave a particular way. All right. I know we are going to go in details. This is just the introduction. Um, I believe. Okay, having known this now, let's go ahead. Let's go ahead. We now talk of what is the benefit of making use of object-oriented programming. Why not use the normal way of programming? Why do we need to stress ourselves on it? First of all, the first one is modularity. Modularity in the sense that when you are producing your application, you produce them bit by bit. For instance, if we are producing an attendance application, first of all, the attendance should be able to register users. You can make users modules. Users supposed to be able to log in. Log in. You can make a modulus. Then we should also make a modulus that calculates how many times a user has come. I don't know if I'm making sense. It calculates how many times user has come. Then we should have a module that outputs the entire result and so many other things. So if you have to develop this application, all these modules will come together. So that's what we mean by modality. So in a situation whereby we want to, okay, let's just understand the concept of modality. Remember this, the use case is attendance system, attendance system. Don't mind me, please. So these are the modules. The first one is what? User. User. You must put a user with a unique ID. Every user should have a unique ID. Then we'll have a login system. Then we'll have that calculates the attendance and the output. So this is the example of what we call modality. Instead of writing the code of that will achieve all these things as one, you write them one after the other, one after the other, one after the other. Then the quality, the property of class is that, or non-object and class is that this one should be able to communicate to this. That means this one should also be able to communicate to this. So that means that the calculation that we are going to have here is gotten from the number of times the person logs in. Are you getting it now? This login now, you cannot log in if you don't have a unique ID in the system. Also, the calculation that you have gotten, the calculation that you are getting is useless if you cannot output it. The calculation you have gotten is now useless if you cannot output it, and so on and so forth. So this is what we mean by what? Modularity rather. That means writing the source code one after the other. Then information hiding by interacting only with the object method. The details of its internal implication remains hidden from the outside world. So if we write this thing in object-oriented form, this object has a property or ability to encrypt data. We also understand those concepts. So you can simply encrypt the whole of this and leave this output open. The user only sees the result. I can only access the code of this, but it doesn't know how this thing is calculated. So it has an advantage for cybersecurity. Then the next one is code reuser. Very simple. We can simply, since we are writing this thing in modules, when we are designing another application, for instance, now we've chosen to design another maybe an exam CBT system now. At least we need these modules. We need a modules that registers users. We need the user modules. And we also need this login. Then we probably doesn't need this. So we'll not leave it. And we also need this output. Then we'll now add questions now. Questions and also add the output. So if you are the one designing this, the only new thing you need to design at this point is this, because you already have these modules and these modules. So that means you have been able to reuse a particular code. So remember we are talking of the benefit of object-oriented programming. So the next thing we'll have here is The next thing we have is it's easy to debug such a problem. So whenever you have an issue, it's easier for you to develop. If a particular object turns out to be a problem, problematic, you can simply remove it from your application and plug in a different object as its replacement. This is an analogy analogous to fixing mechanical problem in the real world. If a bolt breaks, you replace it, not the entire machine. It's simple as it. So if we are not using object-oriented programming, we will not have this ability. So whenever a particular section of the code has issue, you have to troubleshoot it and probably change the whole system. So that is it. All right. Then we cannot just dive into object-oriented because I believe I'll just quickly recap some Java concept. So that you just become familiar with Java. Almost all programming languages are the same. You already know, I believe you're already familiar with all these concepts, variable and data types. We did it in our Python, control structure. We've done these things both in Python and in Scratch and in C, function and method. So once you understand this concept now, we have introduced the course successfully. Then the subsequent days we will now dive into the object-oriented program with Java properly. Okay. All right. This being said, we have the first thing we have is variables. You already know what a variable is. In programming, generally, variable stores values. So what I have here, named stored location in memory used to store data during program execution. So we simply make use of variable to store what? Data. Then we'll talk of data types. It represents different types of data that can be stored, in variables. So you already know what this means. It simply means that these variables accept values. So the values depends on, we have types of values that can be stored in the variables. So we have normal integer, double floats, we have character, boolean, so on and so forth. So at the course of this course, we are going to create on all of them. So I just want to make an overview so that you know that the programs are almost relatively the same. Okay, that's good. Then the next thing is control structure. Okay, let's quickly write a simple Java program. Let's quickly write a simple Java program. And let's go to see your online GB. So now when you open Java, it's simple, very good. So just like in your, hope you see it very well. Just like in the previous program we've done, instead of you using, for example, remember if it was Python, just read print. Just write print. And you now write whatever you want. Print hello. If it was C, you will say printf, right? If it was scratch, you say hello. So in this place now, it's very simple. If you want to put anything in the system, in the console, if you want to make an output here, you simply use system dot out dot print line print ln bracket. You put your distance. So if I want to print another thing, I will simply say system dot out dot print. I can choose to print. Let me print a raw number. Let me say 80. But don't forget your words. Don't forget your semicolon. Without semicolon, it will not run. In other programs, for example, Python, semicolon indicates the end of the statement. So if you don't make use of it, it pardons you because it's a modern program. But this particular language, it's very specific. If you don't use the appropriate word and it's case sensitive, so we are going to see it now. Okay, let me run this now. It will print hello and also print what? It will print hello. So let's see what happens. Can you see it prints hello and prints 80? So it's simple. It's pretty simple, like what we already have before now. Okay, the next thing we have there is, okay, let's declare variables, the types of variables we already have there. Let me check. We have types of variables, we have this. So let's have this now. If I want to declare an integer, we use what? Int variable. We have that. Let me say my age is 50. What do I do? If I forget this, it will not run. If I want to print this, what do I say? I say system dot out dot print line. We go. I can now simply print what age. The rules of variables declaration still contains. So let me run this now. If I run this, have you seen what happens? Thank God. Have you seen what happens? Because I forget this in the age, it won't work. So I have to go and fix it. So I'm already used to Python, so pardon my mistakes. Okay, we'll have this now. Now we see it now. It has not run. It runs hello world print age. So also we have the next. So the first variable data type we have here is what? The first data type we have here is integer. Integers. Of integers. Hope you know, understood what I did here. This is a comment. I want to make a comment. So the next one we have is let's say double. Double simply means so that we can make it a decimal. Let's say I have weight. And my weight is 78.9. So if I print my weight, and let me change this thing to weight. Change it to weight now. If I get it wrong, let's check out the same thing. I still forgot this. It's okay. It's okay. I forgot this. When we keep on writing, all come from there with it. You see now? Then we have another variable types. Variable types are called, I guess it's Boolean values. We have character. Have a variable type called character. These things, we already know these things, so it's not a new thing. So we already know this now. So it's used for what specific characters? We have which other one do we have? We have Boolean. So your probably assignment should be to find out more about data types in Java. Find out more data types in Java. Okay, we'll have Boolean. That's a good one. We know C doesn't have all this type of variables. It doesn't have all this type of variables. So I have this. So if I print this is student now, it either gives me true or what? False is student. If I run it, it gives me true. What happens? I forgot the comma. Right. Pardon me. Okay. Can you see it's true? If I change it to false now. False. It's the same thing. Oh. Okay. It changes to false. Can we see it now? So there's things that are just very simple things. Then the next thing we'll have is, let's quickly go to the next thing we'll have there is, let's talk of control structures. You already know this. When we talk of control structures and the control mechanism, or we simply talk of the flow of the program execution, that which a program executes until a particular, when it can only execute if we have a program, if we have the condition satisfied, just like your if statement. You have your if statement, sorry, we have what? If statements already. We have if statements, and this is the syntax, else. So what you just need just to know the syntax, and let's know, we'll not waste our time on control if. So let's see, let's run this code and see what happens. Let's run this code, use a Java code. Let me just copy it out. Probably I'll copy it out and go to this. We'll copy this thing out. Okay, let me delete some of these things. Let me quickly paste this thing. So this program is not an indented program, unlike Python, but it's just good that you make it so that your work will look neat. If not, it's not an indented program. All right. So this program is simple. If statement, it gives initiate the value of x. It asks if this is greater than 0. Print. This is your print. Remember, your print is system.out.println. Then it should print this positive number. Else it should print negative number. So let's run this by pressing F9, like system. We'll have it. It's going to, what is it supposed to print? supposed to print positive number. Very good. So if we have minus 7, it should print what? Negative number. It should print negative number. Are we seeing it? S is non-positive. Are we there? All right. Then we already know another set of it called the another set of the program known as the control. This is the loop control flow. We have for loop, we have while loop, we have do while. All these things have been stated initially. Make reference to your previous materials. Okay, let's talk about function. So with this function, we can call it a day. A function simply means a block of code. A function means a block of code that performs a specific task. And we have a method is a function defined within a class in Java. So this thing is still the same thing, because when you talk of a method, it's simply a block of code that is inside a class, so that whenever you call that, if you want to access the method, whenever you call the class, whenever you call the method inside the class, it performs a particular function. And is this method that indicates, remember I told you that object has two things. It has a state and a behavior. So is this object that is this method that makes up that defines the behavior of an object? Is this method that defines behavior of an object? So, but that's by the way. Let's just refresh our memory on how to create a variable, how to create a function. In the watch, at this point now, remember this is not Python that just simply you don't need to define the type of variable, a type of function. Neither will you just define, neither will you the parameters. You should remember what a parameter is now. The parameter means the values inside the bracket that can be used inside a function. So these parameters now, you must indicate the what? You must indicate the variable type and so on and so forth. So let's quickly define a variable and see. Let's quickly define let's go back to our code area. Okay, let's quickly define a variable. Let's quickly define a function. Okay, note. It's advisable. Let's not go deep into the structure. Everything you are writing in Python, in Java, must be in object-oriented form. So even our main program is this main class. Are we getting it? So, but just to summarize, every code you are going to write should be in between this function. In between this method, rather, it's no longer called a function. This method called main. Are you getting it now? So main, all these things are the attributes of this method. So it's a void. That means we are not expecting anything. Void. It should be a static one. And it should be accessed publicly. Very simple thing. So let's not just go into the details. The course content is simply what? Object-oriented programming. So we are learning the concept of object-oriented programs. The concept of object-oriented in programming. We are not really dealing deep in Java. So just know this now. every of your code is in, they are going to write is in between this, so I can wipe up the whole of this. Let's make, if I made mistake, I need more code bracket to support the last one. So that means all our code is going to be here. Let's run our code. We have system. Let's run it to confirm. System dot out dot what again? This remember print line. Are you getting it? Okay, already produce this for us. Okay. So I can now make my hello what to confirm. Hello 300 level. 300 level. So let's run this. You should print hello 300 level, I guess. All right. Okay, we can now go ahead. So can you see it now? It print hello 300 level. Let's quickly go ahead. So we are talking of defining a function. Just like in your C, if you want to make a function, you simply declare a function by using, let's declare a function of integer int. Let's say it's some numbers. You put your bracket. I can decide to make it a parameterless, but we can have that. Let's make a global, let me say age int age equals to 5 years old. Then we can now go ahead to add it. Let's make a function called add age. So the detail of this is to add 5 to this age. We'll return it. We are supposed to return it. Well, let's return it. Return age brackets. So if we print this, all right. So if you are to declare a function, you start from you must declare if it's a static function or a dynamic function. So that is it. Let's just quickly run through what you've done, and we'll call it a day. You've done. Let's go over here. We've tweeted about what object-oriented program is all about, and we understood that object-oriented program is actually not a new concept. It has been in existence. So the main purpose of developing object-oriented program is to make our program to look like a physical system, whereby, like your machines, whereby you can choose to change your, for instance, if you have a car, you can choose to change the tire. And the whole car still remains, you can choose to change a particular part of the car. So that's how object-oriented program is. So it has these advantages as modality, modularity, information hidden, code user, and debugging easy. So these are it. Then we introduce ourselves to Java, which is we have talked about variables and data types, control, structures, functions, and method, so on and so forth. So you quickly just write, quickly walk yourself through this assignment. It's very simple. You write a Java program that declares variable to store person's name, age as an integer, height as a double, and the student as a regular. The next one is to implement a Java program that takes an integer input from the user and prints whether it's given or not. So you are going to simply submit the assignment to this base. All right, this is the assignment and this is the course. Just enroll. This is the assignment. This is the course. I getting it now. Just enroll. And you get it. Just enroll. Let's read the assignment. So this is the assignment. Introduction to data. Introduction to data. And it to Java rather. So this is it. This is the question. The program you're already written is in Java. So don't forget to put your main whatever. All right, let's call it a day. Thank you.